So I went ahead and finished filling in the table. You can see over here I did the same thing for 10 and 13. If I changed by 2 to get from 8 to 10 right here, then that means I had to go down 200. And right here I changed by 3, so I had to go down 300. So this also is supported over here. If you go, here's 10, 11, 12, 13 tickets. You can see at 13 tickets, I'm just a little bit above the line. I really should be probably more up here. I should really be right about here. Let me do it in a different color. I should really be right about here, right there. But again, my line was a little off. So if I put my ruler back up there, I could, move it just a smidge. You see, I'm kind of at the top of these points right here. So, but it's close enough. If you gave me that line, I would be thrilled. I'd be happy with it. And then I finished problem number 3. It said, what patterns did you notice? I can't, you have to use your own words right here. But I said, well, I noticed, that as M was going down by 100 each time, the X was going up by 1. That was the pattern that I noticed. And then use the mathematical terminology. Mathematical terminology. It doesn't say explain in context of the problem. It says use mathematical terminology. So they're talking about slope, y-intercept. So the negative 100 right here in this problem represents the slope, or you could call it the rate of change, and then the 1,360 is the y-intercept. If they wanted it in context of the problem, you would say negative 100 represents how much money he spends on each ticket, and $1,360 is how much money he has to spend on tickets. Okay, so here is, I'm continuing in the Springboard book. I'm not on page 17 anymore, but flip the couple of pages and you'll see where I am. Again, it's the same problem. He's won some money. He has that same $1,360 left, but this time he's decided, okay, well, what if I don't want to go to the theater? What if I'm just going to spend it on some meals? And it said on page 17 that if he eats at a nice restaurant, he plans to spend $40 per meal. So now they want to know what function. Here they let us write the function first. Notice they didn't even give us a table. You could certainly generate your own table to determine. But D of M, how much money did he start with? $1,360. And how is he spending it? He's spending it on $40 every time he buys a meal. Okay, they want us to graph it. This is a y equals mx plus b, so we have to start off with 1360. There's the 1360 right about there. And I'm going to go down 40 and over 1. Okay, so down 40 and over 1, it might be easier for me to get some ordered pairs. I know I'm starting off at 0 and 1360, so you see I'm doing a table right here. This is the number of meals, and this is how much money he has. And the reason is because these are counting by hundreds. So I don't know exactly how far down 40 is going to go. And notice that the scale has changed. So they scaled it differently, probably because I'm going to be able to afford more meals. So if I just buy one meal, I'm still going to have $1,320. So where is 1? Well, 1's not a very good number because I don't know exactly where 1 is. What's this scaled by? 5, 10, 15, 20? Yeah, this is scaled by 5. So if I want to see where I am at 5 meals, okay? So, you've got this equation right here, so plug 5 in. 5 times 40, that's 200. So 1,360 minus 200 is going to leave me 1,160. So those of you who need to see the math, 1,360 minus 40 times 5. 4 times 5 is 20, and I've got that 0 right there for the 40. 1,360 minus 200. 2 from 3, so it leaves me 1,160. So that's what went right there. So on 5 right here, I need to be at 1,160. All right, so now that I see, I'm going to go down 1, 2 over here. So now I can go down 2 over 1, down 2 over 1. And I'm not really going down 2 over 1. I'm really going down, what was that? I went down 1, 2, that's 100, 200. I'm going down 200 and I'm going over 5. That's what I'm really doing. Because as soon as I've got that first point right there, I can see what the slope looks like on this scaled axis, and then I can continue the pattern. But of course, you can do it this way. You can say, okay, 10. Now plug in 1,360 minus 40 times 10. So 40 times 10, that would be minus 400, right? 4 times 10 is 40, add the 0. And then subtract 400 away from that, and you would have, I think, 960 left. So at 10, it should be 960. And right here at 10, I'm down 960. So you could keep going like, I don't care how you get it. I just need you to be able to get it. I'm going to try my ruler again. Okay, I'm going to try my ruler. Try to make it match a little bit more. A little bit better. Okay, move it down just a smidge. Move it down just a smidge. Oh, that looks pretty good right there. Pretty good right there. I'm gonna leave it right there, and I'm gonna trace my line. All right, now I won't know how close I got. Oh, I was a little bit off, but I don't know if I can move that or not. Maybe. Yeah, see, it's gonna make me move too much. Okay, so I'm either gonna erase it or leave it alone. I don't think I can move it. Oh wait, there we go. Okay, so now this might help me see, that I'm gonna be able to get somewhere around 20, 25, 30, 35 meals. I don't know exactly where that's crossing, but I can figure it out algebraically. What kind of function is d of m? It's linear. And how do we know it's linear? Because we have a constant rate of change right here. What is the rate of change? And the rate of change is negative 40. How do we know it's negative 40? Because that's what it told us right there. That's how much he's spending each time he spends a meal. So including units, so I need negative $40. Okay, what is the rate of change for the function, including units? And that's going to get me through number 9. I'm going to double check real quick. I don't know if I'm going to end this or not. I think that gets me to number 10. Are all the values for m on your graph valid in this situation, given that m represents the number of meals that Roy can buy? So are all the values of m on your graph? Let's go back and look at my graph. All the values of m. Well, as long as I keep them here, as long as I don't run out of money, then yes, all the values of m. If I go out to 60 right here, 60 is not valid. Why? Because if I buy 60 meals, where's my line? My line's way down here at some negative number. So 60 is not a valid because I'll have a negative amount of money. And if I have a negative amount of money, I've spent more money than I had. So the only number of meals that are valid are the one that keep the line up here in the first quadrant. So that's what I would write on that. Okay, and now if we go back, yeah, that's what I thought. We were down here. What do the x and y intercepts of your graph in number 7? Let me copy and paste this and we'll answer them. I'm sorry, I should have done this a while ago. We're We're going to check your understanding. I think what happened was my kid called me and got me distracted. He was trying to buy his insurance and wanted to make sure that he was his car insurance, and he wanted to make sure that it was a good deal. He needed mama's confirmation. What do the x and the y-intercepts of your graph in number 7 represent? So they're talking about this point right here. This point represents how much money Roy has to spend. And you could put on food, because in this problem, that's what he's spending it on. Or you could put on meals. We should say meals. And the x-intercept, this is the x-intercept. This represents how many meals he can buy with $1,360. So he's runs out of money right here. This is also where he runs out of money. How many meals he can buy before he runs out of money. So there's not just one way to answer the question. You can answer it using your own words and your own interpretation, and you should. I don't want everybody's answers to match when you go do the assignment. If you know the coordinates of 2 points on the graph of a linear function, how can you determine the function's rate of change? They're asking, do you remember this formula? Okay, what is the rate of change? Rate of change is slope. And how do we do slope? What is slope? Slope is rise over run. And if we do rise over run, what gives you rise? The y's. So how do we find the change in y's? We subtract y2 minus y1, and then the run comes from the x's, so we're going to say x2 minus x1. That formula is learned in Algebra 1. We did that up here when we said how far apart are 1360 and 1260. We really said 1360 minus 1260. That gave me 100. And then we said 1 minus 0, okay? And that gave me 1. Actually, when we said 1260 minus 1360, that's how we got the negative 100. So this is the y2 in our formula right here. This would be y2, this would be y1, this would be x2, and this would be x1. So I said 1260 minus 1360 over 1 minus 0. This gave me negative 100, and this gave me 1. So that's how you calculate it. You just use that formula. That's used anytime you have 2 points and you need to find the slope. What is the relationship between the rate of change of a linear function and the slope? They are the same thing. Rate of change is the slope. And use your answers in 12 and 13 to explain how to write the equation of a line when you're given the coordinates of 2 points on a line. You have 2 choices. This is the best one, in my opinion. Y equals m times x minus x1. And for those of you who don't remember this, you can do the mini lessons that you're going to do a Google form, and the Google form is going to ask you some questions. If you answer correctly on the questions, then you get to skip the mini lessons. If you answer incorrectly on the Google form, it's going to take you to some videos